Welcome back, students. In our last video, we discussed about zero of a linear polynomial. In this video, we'll continue to discuss about zero of quadratic polynomials. So consider a quadratic polynomial ax square plus bx plus c. And let us also assume that alpha and beta are the zeros of the polynomial. So remember that quadratic equation, that is equation with degree 2, will have two zeros or maximum two zeros. I will not say will have two, it can have a maximum of two zeros, which means when I substitute this value of alpha in the place of x and try to find out the value of the polynomial, p of alpha will give me 0, and similarly p of beta will give me 0. So friends, let me clarify one thing. In the last video on linear equations, you could calculate the specific value or specific value of that 0 for linear equation, whereas in the case of quadratic polynomial, we are only going to play around with the sum of the zeros as well as product of the zeros and not focus on finding the actual value of alpha and beta. There's a separate chapter 4 on quadratic equations. There you'll be discussing or you'll be finding out how to calculate the values of alpha and beta, that is the zeros of this polynomial. In this chapter, the main focus is on alpha and beta are both two zeros of this polynomial and how to play around with the sum of the zeros, alpha plus beta, and product of the zeros, alpha beta. So for the equation ax square plus bx plus c, the sum of the zeros, that is alpha plus beta, is equal to minus b by a, which is nothing but minus of coefficient x, that is minus b, divided by coefficient of x square, that is a. And similarly, product of the zeros, alpha beta, is equal to c by a, which is nothing but constant term divided by coefficient of x square. So this is a very important formula which you must remember, and there will not be a single question paper which goes off without a problem around these concepts. So memorize these formulas well. So in the case of general form of quadratic equation, using the sum and product of zeros, see the same equation ax square plus bx plus c can be written using the sum and products whatever you calculated as this way: x square minus sum of zeros x plus product of zeros is equal to 0. Substituting the value of sum of zeros, that is alpha plus beta, and product of zeros alpha beta, the equation becomes x square minus bracket open bracket alpha plus beta close bracket x plus alpha beta is equal to 0. This along with the earlier two formulas are very important and must to know formulas. Okay, this is required to solve many problems, and we will discuss the board exam problems in the subsequent videos where I will show how these formulas are very powerfully used. Now just one extra step we will take. We will like we found out that equation we saw in the previous slide. The equation was x square minus alpha plus beta x plus alpha beta. How it was arrived or how it leads to the final equation. Let me substitute this value of alpha beta and alpha plus beta whatever we saw in the actual equation of this. So in the place of alpha plus beta, I put minus b by a. In the place of alpha beta, I put c by a. So the polynomial becomes x square minus b by ax plus c by a. And taking the LCM and calculating, you get the original equation back, ax square plus bx plus c. This is the background of how this equation is arrived. This equation. This is a very powerful equation because in a problem they might give you the value of alpha plus beta, and they may ask you to fix or write down the polynomial equation. So knowing this value of alpha beta and alpha plus beta and this formula, you can write the polynomial equation. So one sample problem, we'll take one sample problem. So the polynomial given is 5x square minus 6x plus 2, and you need to find out the sum and product of the zeros. Before solving, one important tip or thing which you need to keep in mind is fit this formula to the general polynomial equation form ax square plus bx plus c and try to find out what is the value of a, b and c. Why I'm trying to fit is sometimes what they will cleverly do is they will give you the minus 6x first and 5x squared the second term. So what would happen is if you directly start solving putting equation minus b by a, you will end up in the wrong value of alpha plus beta. So you must fix it in the same sequence. A square term first, then x term next, then the constant term next. So this sequence must be followed. Only after that you must figure out the values of a, b and c. So now in this cases, a is 5, then b is 6 and c is 2. So we know the value of sum of the zeros. Sum of the zeros is alpha plus beta is equal to minus b by a. B is minus 6, so minus of minus 6 by 5 is 6 by 5, and product of 0 is c by a. So c is 2 and c by a is 5, 2 by 5. So this is how we calculate the product of the zeros. So friends, let us connect in the next video on how to work with zeros of a cubic polynomial. Bye till then. Thank you.